Good morning, everyone. Today we're going to continue our discussion on uh, performing multiple linear regression, and we were validating the result of the LM function using matrix algebra. So may I request you, maybe you should create a new RMD file just to make this, just to, okay, of course it depends on you. You may wish to create another RMD file for this particular topic using matrix algebra for multiple linear regression. So these were the packages that we used last time. You can just copy it from the previous RMD file. So we're loading these packages, psych, HMIS. These are packages that we use for descriptive statistics or EDA, exploratory data analysis. What's most important for us are tidyverse and then OLSRR, so we're going to use later, and perhaps Stargazer. But let's just throw in these other packages. So if I run this, okay, why don't I delete everything first here? So I'm erasing the objects in my environment so that I'll start from scratch. Okay, I'll load these packages. Okay, once they're loaded, I'm going to upload again the wage data set. So I'm starting from scratch. And since I'm using the R project on multiple linear regression, the wage data set is saved in that project, so I can easily access that data. So read underscore CSV. And we can access this because this comes from readr, which is, uh, if I check my packages, readr, okay, it's already checked because this comes, uh, this is a dependency of the tidyverse package. So this was automatically loaded also. So if I run this, I'm going to have the uh, wage data, okay, loaded here in my global environment under data. Waiting for it there. Okay, and we've seen this data several times. And it declares to us that race, gender, and civil status are character variables. Okay, if I run this structure function, and then we can see here that that education, experience, tenure are all numeric. The three character variables are race, gender, civil status. Okay, so it's okay to create a linear regression model, even if the variables are categorical, because automatically R will convert them into factors. Okay, so we did this before. In fact, if you if we go back to our previous RMD file, we we run a regression model. Okay, where's that? Okay, so going down, we run a regression model where okay, I think it's here. So, mhm. Okay, here, where we regress hourly wage on all the features, on all the variables, on all the independent variables. Okay, then we were able to run this and it generated an output. Okay, even if race, gender, and civil status are all categorical variables, automatically R knew what to do with that. Okay, so in this case, what we're going to do is we're not going to use the LM function. Okay, why don't we do that here? I'll just introduce that here. Okay, I'm going to create a model called mod1, control alt minus, and then LM hourly wage shift regressed on. Okay, let me just get the names of my names of wage here. Names of wage, control enter. Okay, so that I'll just copy this and just control C, control V, and just delete accordingly. So I think for me it's faster rather than typing and deleting those that are X per plus tenure, delete plus race plus, I should just have copied the one in the other gender. Okay, you can just copy the one on the other RMD file. That should have been faster. Okay, civil status plus number of dependents. Okay, delete hourly wage there, delete, comma, data is equal to wage. Okay, so you know this very well, class. Okay, you know this function very well. Okay, so we're regressing hourly wage on all these variables. We're calling it model one, and we were able to generate the result of this, and we can include here summary model one. Okay, I'm going over this very quickly because we have done this several times in the past already. Okay, so this is our model. Let me rerun that. Okay, what happened here? I'm sorry, I ran the wrong code chunk. This one. There. So we can see here the values of the estimates, the values of our parameters, our independent variables, together with the intercept, the standard error, the t-value, and the probabilities, the p-value. Okay, what we're going to do now is we're going to replicate this using matrix algebra, okay, which we started already doing last time. We were able to generate this, but let's have a quick review of that. I'll close this, okay? And we said to do that, we will have to create, if you recall, class, the formula, okay, the formula for our beta, okay, our predicted beta is, okay, I hope you recall this, is equal to x transpose x, then create the inverse of this, and then x transpose y. Okay, where x is a matrix of your x is your matrix of independent variables together with the intercept. So your x will look like this. It's a matrix. Okay, and then this is your, for the intercept, for B1, which is education, experience, etc., and there are seven independent variables. Your intercept will be a unit column, so all ones. And then for your education, okay, it will be, let's take a look at the wage data. Okay, so difficult to close this. This is wage. All right, so it will be this one. Sorry, this one. This matrix here, excluding hourly wage. So it will be this one, from education up to number of dependents. Okay, this whole matrix. Okay. All right. So that's what we intend to solve. X in X transpose X, then the inverse of this product, and then X transpose and then Y. Now we showed last time that this was indeed the formula for computing for the betas. Okay, the first column in your output, the values of your uh, the coefficients of your variables. Okay. Could I have a thumbs up, please, or a yes, if this is clear to us, class? This very important equation, this very powerful equation, which makes computing really very easy in order to solve for your coefficients. And behind the scene, see R class. It's what R is using. Nagme-matrix algebra yan in order to generate the LM. Otherwise, kung pagta-trial and error yan, it will take eternity. But you notice when we run LM, automatically lalabas yung ano. So behind the scenes, may code yan ng linear algebra, and this is being done. And since computing power now for computers are quite fast, it can easily generate the value for our betas. Okay, may I have your comment, class? Your confirmation if so far clear tong formula na to? Itong X transpose X inverse X transpose Y. I'll wait for the others to give their comments. So in fact, this should be 11, okay, 11, and then 12. So just copy this row here, and then for education for B2, it will be 222, etc. 222, etc. Okay, thank you so much for your feedback, although I'm not getting 50% class. What about the others? You're 36 here and I'm only getting 14 responses. That's quite a poor response rate. Okay, how about the others? May I ask you for your feedback, please? Okay, that's a lot better. I hope we can reach even 30. Just for me to be convinced that you, unless you have any questions. Okay, clear. Okay, good. Thank you so much, class. Okay, so this one, of course, this will be included in your exams. Yung function na to, no, X transpose X, X transpose X inverse X transpose Y. Your Y is your vector of your dependent variable, this one, hourly wage. Okay? All right, now the problem here is that ito, yung race, gender, civil status. Okay, so when we do the model.matrix function, R will automatically convert this. Okay, so the default of R is 2. Okay, so race has 2 levels. You have white and non-white. What it will do is that the level that will appear first alphabetically will be the benchmark. So it will be given the value of 0, and then the other one will be 1. Okay, so if there are 2 levels, there will be how many dummy variables? There will be 1 dummy variable, because the number of dummy variables will be n minus 1, where n is the levels. Okay, how many levels? How many different types of race? White and non-white. So 2 levels, 2 minus 1, you'll have 1 dummy variable. Dummy variable, which means there will be only 1 column here, 1 variable. If there were 3 dummy variables, okay, for example, you have, let's say, part of this is either living in Makati, or you're living in Manila, or you're living in, let's say, Quezon City, for example, only. Okay, so if this was part of your categorical variable, residence, what R will do is that it will arrange this alphabetically. And since Makati is the one that will appear first alphabetically, then this will be given a value equal to 0. This will be the reference or the benchmark. Manila and Quezon City will be both given 1. So how many dummy variables will be generated? There will be two dummy variables. Okay, why only 2? Will all the levels be captured if there are 2? Yes. For example, the first respondent is Makati, and then Manila, and then Manila, and then Quezon City, and then Makati. Let's just suppose these are the respondents. These are the observations. So for the first one, Makati, okay, there will be no dummy variable for Makati. It will be only 2, Manila and Quezon City. So if the respondent is Makati, then this will be 0 and 0. Okay, if it's Manila, then this is 1, this is 0. If it's Manila again, 1, 0. If it's Quezon City, 0, 1, and then Makati again, 0, 0. So which means that even if you only have 2 dummy variables, okay, it captures all the 3 levels. Again, is Makati captured? Yes. If R sees that this is 0 and 0, then that means automatically that's Makati. Okay, so please remember that. Okay, the number of dummy variables will depend on the number of levels. Okay, if there are 5 levels, then there will be 4 dummy variables. Otherwise, if there were, if the number of dummy variables were the same as the number of levels, that will you will have what we call a dummy variable trap. Okay, there will be perfect multicollinearity. Okay, there will be a problem like that, which we're going to show when we go to diagnostics. But suffice to say, class, that these categorical variables all have 1 levels. So we expect 1 dummy variable for each factor. Okay, so when this is translated into a matrix, okay, it cannot just maintain the character variables, okay, the characters. Okay, you cannot perform this operation if these were only characters. So this would have been changed. Okay, this would have been converted into a dummy variable. So since the default is that the one that appears alphabetically first will be 0, this one will become 1, 1, 1, 1, 1, 1, etc. And if there's a non-white, then that will be 0. Okay, for gender, okay, female and male, female will be the benchmark. So female will be 0, 0, 1, 1, 1, etc. For single, married will be the benchmark because it appears first alphabetically. So this will be 1, 0, 0, 1, etc. So automatically this will be converted into numeric. Okay, numeric. Okay, usually it's 0 and 1. Okay, may I have your confirmation if that's clear to you, class? Kindly please chat yes or no if it's clear to you. Okay, thank you. All right, so you know what will happen, class, if there are categorical variables. Okay, and of course we will only allow categorical variables that can be used as a factor. So for example, if there was a field called address, okay, address, specific address, for example, your house number, etc., most probably that would not be used as a factor. Okay, that would not be used as a factor because it's let's say you're taking a look at a study where students study about students, and then these students are coming from different houses. Okay, so it will be useless, class, to have the address as a factor. You know why? If there are, let's say, 1,000 respondents, and there might be 1,000 addresses also, unless you have, let's say, brothers or sisters in one house, then they'll have the same address, but that might be very few. Okay, so be discreet, be discriminating about a factor, especially when you have your case. Maybe you'll come across a particular categorical variable, and let's say zip code. Okay, unless the zip code is very important, then unless you're trying to classify and try to see whether there's a difference in the effect of zip code on a particular variable, then use that. Otherwise, it will be useless. Okay, so I hope that's clear. Let me clear the drawing first and then close this. And let's now go back to our model. Okay, so we will have to first create the x's and the y's. So this is what we did last time. X is equal to, we use the model dot matrix, okay? And we use the model dot matrix gender, race. Okay, let me just control X. Let me control B. And education, experience. Let me use the order race, control X, race, and then gender, plus civil status. Again, I think tenure is here. Okay. I just rearrange this so that it will be the same as the previous one. Okay, so we're creating the model dot matrix will create the X matrix where you have all the independent variables. Okay, so let's run this. Sorry, this should be data. Data is equal to wage. Okay, and take note, although we didn't put here the intercept, automatically that will be created by see here intercept. Okay, it included the intercept. So this is for the model of our LM. Okay, using matrix algebra. Education, experience, tenure. Notice class that it automatically converted, diba? Race white, okay, which means all the white here will be 1. The non-white will be 0. Gender male, the male will be 1. Okay, the female will be the benchmark, kaya 0 siya, di ba, yung unang dalawa, okay, etc. Okay. All right, so what do we do next class? And then we also create y. Y will be the dependent variable wage, dollar, hourly wage. We create y, and we have y here. And to take note, y will just be a vector. Unless we make it into a data frame. But it's just a vector because it's just one column and it has the same elements numerical. So it's treated as a vector here. Okay. So when we run this class, naran ko na, no? We now have x and y. Okay. And then, all right. If I run this, okay, I repeated it kasi what will happen, class, if I teka muna, class. When you run x and y, did you generate this? Did you automatically generate this, class? Ones and zeros. Feedback, please. Kindly chat. Yes or no? Yes, yes, yes. Okay, good. Yes, yes. Okay, good. All right. So with that, can we now use this? Okay. Remember last time we first get the transpose of x and then multiply it by x and then get the inverse. So to get the inverse, you use this solve. Okay, so here you're getting the transpose of x multiplied by, so in matrix multiplication, in R, you use percentage, asterisk percentage, and then x. So this is the transpose of x multiplied by x. And then to get the inverse, you append solve there. Okay, solve. And then after that, what do? We matrix multiply it to the transpose of X multiplied by the, or you can, it's possible for you to multiply it first by the transpose of X and then multiply it by Y. Okay, so that's also possible. Kasi R will solve it this way. It will solve this first and then multiply it to the transpose of X and multiply it to Y. Or it's possible to matrix multiply this first, put a parenthesis there. Okay, so that's also possible. It will give us the same answer. Okay, if I run this, and we now have our betas here, betas class, this one. And it's a matrix. We know that it's an 8x1 matrix. We tested this last time. And these values are exactly the same as the LM values. Okay, this is a numerical vector. Let me go here, class. If I print betas, control enter. Okay, here's my betas. And if we compare it with the result here, summary model 1. Okay, I'll print here summary model 1. Control Alt I, summary model 1, the LM. Okay, I should have used. Okay, I should have used coef. Okay, coef, the coefficients. I don't want the whole model. I just want the coefficients there. Okay, intercept negative 3.389. Okay, education 0.5745846. Okay, so we did this last time. Okay, and we were able to validate that the LM function generated this matrix operations generated the same result as the LM function. Okay, now for the other outputs, let's say like the standard error, the t-values, the p-values, we're going to also generate that using formulas. So let's calculate first the residuals. Okay, so how are the residuals calculated? You know very well that residuals are calculated by comparing your actual value minus your predicted value. Okay, actual value of Y, which is your hourly wage, minus the predicted value. Okay, how do we get the predicted value? How do we get the predicted value? So we know that the betas, okay, the predicted value Y is equal to, it's your X matrix multiplied by your B matrix. So your predicted value is equal to your X matrix. What's the size of X matrix, class? Kindly unmute yourself. Anong size ng X matrix, please? Hello, class. X matrix, what's the dimension of X matrix? How many rows, how many columns? Class, hello. Okay, kindly unmute na lang, please.
Sir, 526 by 8.
Yes, correct. 526 rows by 8 columns, right? This includes the intercept and the independent variables, which are 7. How about our B matrix, class? What's the size of our B matrix? This is how many rows?
Sir, is it 1 by 8?
8 by 1, okay? 8 rows by 1 column. Okay, thank you. 8 by 1, not 1 by 8. Okay, so is this multiplicable? Yes, kasi the column of the first matrix is the same as the row of the second matrix. And the resultant matrix is 526 by 1. Okay, so the y here, class, 526 by 1. So it's one column consisting of all the predicted values per row. Okay, so we can write this as y. We have y, class, minus this one is actually x times your B matrix. So we have your X matrix, you have your B matrix. We'll just matrix multiply this, and this will now generate your residuals. Okay, so let's do that. Let's calculate the residuals. So let's create this object residuals, or maybe let's just shorten it, resid, and it's equal to y minus, what's the matrix? X matrix multiply betas. You have betas, right? This is our 8 by 1 matrix. Okay, let me see my question dito. Yeah, thank you, Migs. 526 by 8. Okay, so we're creating these residuals. So let's run this first. Control Enter. And we will now have this. So your residuals, okay, so this is a data frame consisting of one row, 526 rows, and one column. Okay, if let me get the head of receipt, first three. Control Enter. So these are the residuals, and let's compare that with the seed. Okay, residuals. So we have a function residuals of our model 1. Okay, and I'll just get also the first three observations. Head of the residuals. Okay, take a look at this. What am I doing here, class? I'm using the function residuals of model 1. Okay, and then I'm using the head to generate for us the first three observations. And if we compare this, Control Enter, just to see if they're the same. Okay, pareho ba, class? Exactly the same. Okay, let me pause for a while just to allow you to catch up. Maybe I'm going too fast. So what did we do here? We created an object called receipt, and residuals is just your actual value of y minus your predicted value. How do we get the predicted value? You have your X matrix. Matrix multiply it with your betas. Okay, you'll get your predicted values. And maybe I'd just like to demonstrate that. No? Okay, so we have here, just to, your betas will be, this is your beta null, this is your intercept, B1, B2, until B7. And our X is, we know our X class. This is our B0, B1, B2, until B7. And the first value here is 1. And then this is the value for education, experience, tenure, etc. So when you do matrix multiplication, okay, so this is 526 by 8. This is 8 by 1. What you do here is that this row here is multiplied to the column here. So that will be 1 times intercept, and then the value of education multiplied by the intercept for education, and then the value of experience multiplied by the intercept for experience, okay, and then etc. And what do you get here? This will be the predicted value for y sub I for the first observation y sub 1. Okay, so it can be shown that indeed, when you multiply x by your b, you're actually getting your predicted values. Okay, does that make sense, class? Could you kindly chat, please, if that's clear, or you want me to repeat that explanation? I just wanted to show to you that indeed multiplying x by b will give you your predicted value. Take note, it's x times b and not b times x. Okay, you know very well from your FINARTS that matrix multiplication is not commutative. All right, thank you. Thank you for, although I don't see the others, no, parang 6 lang yung nag-respond. Kamusta yung iba, class? May I have also your confirmation? Unless you want me to explain again, no problem. Just tell me, class. Okay, good. All right. So let's just, let me just, saan yung model 1 natin? Summary ng model 1. Okay, let me just again go back to what our intention is. Our intention is for us to generate this. We have already generated this. Okay, how about this? The standard error, si t value at saka p value. We can do that, plus using matrix multiplication. The same thing with how we did to create the estimate. So we're now moving towards the standard error, and then the t value, and then the p value. So the standard error is simply just like the standard deviation of your residuals. Kaya a standard error. So you know how to get the standard deviation. Standard deviation not of the values, not of your dependent variable, but the standard deviation of your residuals. So there was a need first for us to compute the residuals. Okay? So I hope you're getting this, no? Why are we computing for the residuals? Because we need to compute for the standard error. What's the standard error? The standard error is simply the standard deviation of your residuals. Okay? So in order to get the standard deviation of the residuals, you have to identify you have to come up with your residuals first. Okay, so let me call this sum of the squares of your residuals. So let's just change the name, okay? Let's call it SSR. So take note, later on may RSS din dyan. Kasi some call it RSS, some call it SSR. So let's just use the standard that's used usually in books. So it's sum of the squares of your residuals. So how do we get that? Well, since we have already the resid, so let me, okay, we have the resid, right? We created this vector, this data frame of residuals. Then we can just get the square of that and then sum it up. Okay, so that's the sum of the squares of the residuals. So ini-square muna natin sila. Now, take note, class, if we just get the sum of the residuals, this is what I told you before. If we just get the sum of the residuals, okay, it will give us, okay, so let me print this. So we're getting the sum, okay. So I'm printing it. Okay, bakit ano? Bakit may exponential? Recede. Tama naman. Tama kasi dito na lang. Ini-error niya yung may ano SSR. Okay. So i-print natin yung SSR. Control Enter. Okay. And this is practically 0. Diba? It's 0.000022, etc. So this is proof that indeed the residual squared is the residual, sum of the residuals, summation of E class is equal to 0. So that's why this OLS does not use the residuals, but rather the residual squared. So we square it first, class, then we get the sum. So there will be only one answer here. Because you have 526 residuals, and then you square that. And then you get the sum of that. You also get the SSR here. Control Enter. All right, so SSR is 4508.078. Had we used the, let's use the residuals. No? Let's create SSR1, and let's use the residuals. Okay, or you can use mod1 dollar. Okay, we can get the residuals of mod1 here, class. So mod1 contains the residuals, diba? Tab. So this is now the residuals of mod1. And there are 526 residuals all in all. What we're going to do is we're going to square this. Okay, square this. Okay, and then get the sum. Sum, close the sum. Okay, and then let's print SSR1. Okay, so I'm creating this other object SSR1, which is we use model 1, okay, the result of the LM function, and then we access the residuals. What we did with this is we squared this, and then we got the sum. And then I assigned it as SR1, okay? And then let's run this both. Let's see if they give us the same answer. Control Enter. Okay, exactly the same. Okay, exactly the same. Okay, what's our intention here again, class? Our intention is to replicate the LM function, the LM model. Okay, so we first computed for the coefficients using the X transpose X inverse X transpose Y. And then from there, we use this formula. We got the residuals, which is just the difference between your actual value minus your predicted value. This is our predicted value. Okay, so we generate this this object, and we compared it with the actual residuals coming from the model output, and they're the same, class. And same thing here. Same thing here. All right, now, okay, this is not what we really want. What we need is to compute for the standard error. But we need first to have our degrees of freedom. Okay, what is the degrees of freedom, class? If you recall, class, the formula for degrees of freedom is n minus k minus 1. That's our degrees of freedom. What's n? N is the number of observations, and then minus k is the predictor, number of predictors, and then minus 1. Why minus 1? Because we have to subtract for the inclusion of the intercept. Okay, because we're also predicting the intercept. So we lose 1 degree of freedom because we're adding the intercept to our model. Okay, so this is actually 526 minus k. K is your number of predictors, which is 7, and then minus 1 to account for your intercept. And this is just n row of x. Okay, the number of rows of x. What's n row of x, class? So let's run that here. We know the answer to this, n row of x. So n row of x is 526, right? And then how about n column x? N column x. Now, x contains also the intercept, right? So that will be 8. Because it contains the independent variables, 7 of them, and 1 in the intercept. So that makes 8. Which is just this one. Number of observations minus number of predictors, which is 7, minus number of the other one, intercept. So this is 8. Okay, so we can define our degree of freedom to be number of rows, which is number of observations, minus number of columns of x, which is predictors, and also the intercept. So this gives us, okay, yeah, df is, let's print df is 518. Okay, let me pause for a while. Okay, may I ask, class, if you're following? Clear ba tayo, class? Why are we computing DF class? Because we needed to compute for SSE, SSR, sum of the squares of your residuals. Okay, how do we compute for SSR class? We have to have the residuals, and then we have to have the degrees of freedom. Okay, all right, good, clear. So we now first compute for the variance. Okay, so this is step by step SSR. Okay, so our variance, which is sigma squared, so this is now the variance of your residuals. The variance of your residuals of our resid. We called it resid, right? The variance of the resid, and it's equal to the sum of the squares of your residuals divided by the degree of freedom. Okay? So when we get the sigma squared, which is the variance, we can now easily get the standard error. Okay, so let's run this. And what will this give us? Let's check. Sigma squared class will be this one. So what is it? SSR is one value, right? DF is one value. So the variance of the residuals is this one, 8.70 something. That's the variance. Okay? And after we have computed for the variance, what we'll do first is we will have to compute for the variance covariance of our beta. Okay, so medyo may process pa, no? So let me just show you what's happening here. So this is your sigma squared, this is your variance, and we multiply it by the transpose of x, okay, multiplied by x. And then we have here inverse. There. So take a look at this class. It's the sigma squared, it's the variance multiplied by x transpose, okay, times x, sorry, not minus, okay? That's not minus. This is x prime. Okay. And, so what happened here? X prime. Okay. X prime x inverse. Sorry about that. No? Transpose class is x prime, not x negative. Okay, so this is the formula to compute for your variance covariance. Okay, so variance covariance will be equal to the variance of your residuals multiplied by the x transpose x inverse. Okay, so we're getting the variance covariance. Okay, so let's compute for that first. We delete this. Okay. So variance covariance is equal to the sigma squared multiplied by the x transpose x quantity inverse. Okay, so let's run this. Okay, and let's see what the variance covariance is. So the variance covariance class will be an 8 by 8 matrix. Why is it called variance covariance?
Why is it called variance covariance? Is it called
Okay, sandali may question dito. Code chunk before that for sigma squared. Okay, I'm sorry, I'm going too fast. Okay, sigma squared. This is the code for sigma squared here. So to compute for the variance of the residuals, okay, it's your SSR, sum of the squares of your residuals, divide by the degree of freedom. Okay, and then from there, we can now compute for the variance covariance. Okay. So once again, let me flash the variance covariance of our betas. Okay, so you have 8 by 8 matrix to, no? 8 by 8 matrix. So why is this called variance covariance? Why is this called variance covariance? Okay, if I pair, for example, intercept and intercept, the variance of intercept with intercept is the covariance of intercept with intercept is the variance, okay, variance of intercept. Okay, how about education and say education and number of dependents? This is the covariance of education and number of dependents. How about this one? What's this one? This is the covariance of intercept and tenure. Okay, so all others are covariances because it's the variance of two different variables. Now the diagonals here, ito, these ones. The diagonals of your variance covariance is actually the variance of the variable. Okay, so this is education with education. The covariance of education with education is the variance of education. The covariance of experience with experience is the variance of experience. The covariance of number of dependents with number of dependents is your variance of your number of dependents. So that's why this is called the variance covariance matrix, because it consists of the variance of the variables with itself and the covariance of the variables with the other variables. So from your stat, okay, if you recall, what's the formula for variance? Variance is simply equal to summation of x minus x, okay, x bar, okay, x sub I minus x bar, and then also x sub I minus x bar. Okay, or that's your x sub I minus x bar squared, right? Divided by your n minus 1. So this is your variance, or you can square this. For covariance class, covariance of 1 with 2, so you don't put squared here, okay? Or you can write this as covariance of 1 with 1. This one is covariance of 1 with 2, so this is equal to sum of x sub I minus x bar times y sub I minus y bar. So mag-ibang variables, no? Over n minus 1 if it's a sample, or over n if it's a population. Okay, so we were able to generate our variance covariance. Why do we need the variance covariance class? Because this will now be the source of our standard error. So how do we compute for the standard error? Okay, let's just quickly review class, ha? So ano yung steps na ginawa natin in order to compute for your standard error? First, we computed for the residuals. Then we computed for the sum of the squares of the residuals. Square natin residuals and then get the sum. And then we have to know the degree of freedom, which is very easy, n minus k minus 1 lang. And then we get the variance, estimated variance of the errors. So that's SSR over DF. And then from here, we compute for the variance covariance, which is just whatever your variance is multiplied by the inverse of the transpose of x multiplied with x. And then finally, this will be your standard errors. So take a look at this class. Okay, I said a while ago that the diagonals will be the variance, right? So if we get the diagonals, so this function will get for us the diagonals. Okay, so let's try to see first. Let's maybe here. Let's create this object diag. Okay, and let's see what happens if we get the diagonals of the variance covariance. Control C, Control V. So just to illustrate this, I'll just use die para baka magka-confusion. Die for the diagonal is equal to diag ng variance covariance. Control Enter. All right, let's see what this is. So the diagonals is a vector. Okay? Ito siya. So i-print ko die, print natin. So it's this one. 0.87, 0.0027, and if I go here, class, 0.857, 0.0027, it's exactly the diagonals. Okay? So we were able to extract the diagonals. Now, okay, sige. Kumpletuhin ko na lang diagonals. Okay? So that the standard errors will simply be hindi, pangit. Kasi may diagonals tayo doon. Actually, pwede. Sorry. So that's the diagonals. I'll run this. And then it will simply be what class? Okay. The diagonals are the variances. How do we now get the standard deviation? So that the standard deviation of that variance covariance, the standard deviation of the diagonals of that variance covariance matrix class is your standard errors. Okay, so let's run this standard errors. Okay, and let me print this. Standard errors. Print ko na lang. Okay, print natin. And tell me please class if it's exactly the same as the value in summary model 1. Kindly check class. Compare this with the value of the standard errors. Model 1 dollar. Okay. Andito siya, no? We can get it here. So I forgot what to, hindi siya effects eh. Okay, anyway. So degree of freedom of the residual contrast X levels. Okay, I forgot to get it from this one class, but you can get it from the model 1 class. No? So i-compare nyo lang class dun sa ano, sa summary ng model 1. Is it the same class? Is it the same? Kindly feedback please. Are the standard errors the same class? The standard errors that we generated using matrix multiplication? Waiting for your feedback class. Hello class? Same. Okay. Let's wait for the others to confirm if they're the same. The advantage of trying to see how this is computed is that you have an appreciation, a better appreciation, appreciation of how these outputs are generated. So you're parang ano, you know better, no, than just, yan. How was it generated? I don't know. Lumabas lang yung output na yan eh. And we said that linear algebra together with calculus kasi are very powerful tools. They were used actually. Yung LM function, ang ginamit niya, itong mga formulas na ginawa natin. So we were just looking at the box that are used in order to generate these values. Okay, I hope you got it, class. I hope nakita natin na same yung ano. Okay, so ano pa yung kulang? Meron tayong coefficients, meron tayong standard errors. Okay, so let me just put this one here, summary, odd one. Okay. So these were the standard errors. Of course, class, they will be all positive. Kasi they're the square roots of the variance. So hindi pa pwede magka-negative tong standard error. All right, then how about the t-value? How is the t-value computed, class? The t-value is easily computed by just getting the quotient, okay? The t-value is simply your estimated b sub I divided by your standard error. There. So if you divide this, that will simply be your t-value. Okay, negative 3.38958 divided by 0.92628. Kindly confirm, class, if you get this value by dividing estimate by the standard error. So these are our betas. This is our standard error. And our t-value will be equal to beta b sub I divided by the standard error. Kindly confirm, class, please, if your estimate divided by the standard error will give us our t-value. Okay, confirm, class. Yes or no, please? Okay, good. Thank you. All right, so, okay, then let's compute now for the t-values. So, well, just the division, class, diba? So our t-values will simply be equal to the betas divided by the standard errors. Very pretty straightforward. So we're creating this vector of t-values, which is just your betas divided by standard errors. Let's run this, and we now have our t-values. T-values. So wait, t-values. Okay, here, class. These are our t-values, and this is exactly the same as the model 1 output. Okay, and then finally we go to the p-value, class. P-value. All right, so how do you compute for the p-value? Okay, so let's illustrate that for us to know. Okay, so this is your t-distribution. You know that the t-distribution is symmetrical. This is like your normal distribution. Okay, so we know the t-value, and the t-value can be negative or positive. So for example, let's take a look at ano ba yung t-value ni ano? Okay, let me clear this first. And let me first put here let me print the values. Okay. Okay. So these are our t values. Okay, how do we now compute for the p-value? Okay, if you recall from your statistics, okay, so dapat maintindihan natin yung formula na yan para in case kunyari bigyan ko kayo ng p-value tapos tatanungin ko sa inyo sa exams kunyari or wherever, no? How do you compute for the p-value, getting the t-value? So take note class, yung inference natin it can be based on just looking at the t-values or the p-values. You can infer if you're going to reject the null hypothesis based on the t-value or the p-value. Okay, so let's take a look at this. Si t-value daw class. Okay, so si enters, let's start with education. So it's 11.03, no? And this is the same as negative 11.03. Yan. Positive or negative. Okay. Now, ang question, ano yung p-value? Ang tanong kasi class, ano to? Yung p-value is the probability. Itong area under the curve. Yan. Yan ang tinatanong sa atin. If we can get this, and this class, we sum this up, yun yung p-value natin. That's the probability class, no? Okay, yung probability yan. Okay, so the function that we're going to use is p. Okay, so we're looking at the probability ng t distribution. So that's why you notice here, class, it's pt. Okay, p times t. So if you're looking for the probability, the area under the curve of your t distribution. So t distribution to, di ba? Kung normal sana to, pn yan, no? Okay? Kaso t distribution to, so pt. P class is when you look at the p value, the probability, and t stands for your distribution. Anong klaseng distribution? So sige nga class, paki-ano nga, kindly chat in the chat box class, mag-view ng help ni PT. Okay? So ano yung parameters na kailangan class kay PT and what does that give us? So sa console class, i-question mark nyo PT and may I have a volunteer please na paki-chat kung ano yung nakalagay dun sa, kasi sorry, hindi nag-work yung ano ko hindi nag-work ngayon yung internal service error ako. So I'll stop share. Can somebody please share screen and please share to us ano lumalabas dun sa question mark PT? Anyone? Sige, ikaw na lang Julian please. Ikaw naman yung na pangalan. Julian, Mr. Santico. Hello? Are you ready, Julian? Wala yata. Hello, Julian, are you there? Paki-chat if you're there. Yun ang mahirap class sa ano, no? I'm not singling out Julian, pero okay, sige, diyan ka. Sige, who can share class his, her, or screen now?
Hi, sir. I can.
Sige, thank you. Sino to?
Ali po.
Sige. Ali, please.
Sir, naka-disable po.
Ay, sorry. Oo nga, no. Yan. Okay. Sige, please. Ali, kindly share your screen. Tingnan natin yung ano, yung PT na function. Alright, to class, no? Yan, tingnan nyo yung iba't ibang yung iba't ibang function. dt, yung distribution. pt, this will give us probabilities. qt naman, okay, quantiles to. Tapos rt, iba din to, no? So what we're interested in is the probability, the p-values. So itong sabi, no? pt. So kailangan natin yung q. Okay? What's q? Tapos degree of freedom. Tapos, ano ba to? Lower, ang default nito, lower that tail is equal to true, no? Okay, so this is the function that we need in order to compute for the probability, PT, okay? So T stands for the distribution. So if you're looking for the probability ng normal distribution, Pn yun. Okay, because there are, kung F distribution, PF. Okay, so just be aware of that, no? PT. So Q muna, tapos degree of freedom. Tapos we can just ignore this kasi pwede namang default naman to eh. O, sige. So thank you, Ali, no? Thank you. So sige, I'll share screen again. Okay, share screen para ma-solve na natin to. Okay. All right. Bakit ganito yung formula ko, class? Okay. So, ang t-value, for example, sa education, no? Okay. Let's solve this first na, one at a time, no? So, kunyari, p-value ni education. Solve natin si p-value ni education. So, sabi natin, yung p-value ni education, di ba yung t-distribution natin, ganito? Yung kanina, no? Ito yung negative 11.3. Tapos ito yung positive 11.3. Okay. Ang p-value niya, class, itong dalawa. No? Dapat i-consider natin yan yung two-tailed kasi ito, no? Ito at saka ito. So what we can do is, we can compute muna, ito muna, class. Tingnan natin, no? So, we use PT, diba, here. Okay, sorry. So ang quantile natin, class, 11.3, di ba? Ito yung value natin. So ibibigay natin kay R2 11.3. PT. Tapos degree of freedom natin yung kanina, yung DF. Pero ito lang yon, class. Di ba? It will only give us one side of the T distribution. E paano to? Kaya nga natin dapat i-multiply ng 2. Okay? So, sige, gawin natin yung just for the education. Ano nangyari dito? Uy,